Guys, we've all seen the spectacular images from the United Airlines Boeing 777 that experienced this spectacular engine failure outside of Denver last Saturday. So instead of me going in to review the entire sequence, a lot of great YouTube channel has done that already, I'm going to be focusing on the questions that you guys have sent in to me via Twitter, via Facebook, Instagram, and let's just dive straight into it, shall we? Yeah, oh, I love this one. So Alex Patterson is asking on Twitter, does the person whose garden the engine cowling landed in get to keep said cowling? Okay. I don't pretend to know the legislation in all of the countries that this could potentially happen to. But what you need to really understand here, guys, is that if you are sitting out in your garden and it suddenly starts raining parts of engine and aircraft down on you, first of all, get out of there quickly, right? Take cover. Don't film it, like I've seen people been doing on the internet. Secondary, leave it alone and contact law enforcement or your local government, because these parts is going to form a really important part of the ongoing investigation and to try to figure out why this happened in the first case. So don't touch them, don't move them, just let the local authorities know. They will know what to do. They will probably come out and collect it. So even though you could use them to build the most awesome barbecue in the world or create your own jacuzzi, don't, okay? Let the authorities gather up this. They are going to need to use them, and then who knows, once the investigation is over, maybe you could claim them back. I don't know, it's possible, but don't touch them to start with, okay? Right, this one is really interesting as well. So Ani Ruda is asking on Twitter, they would have done a pre-flight walk around for sure, haven't they? Yes, and I want to just emphasize here what we try to do when we do a pre-flight walk around, as in both us, the pilots, and the engineers. Now, what we're looking for when we do the walk around is obvious damage. So bird strikes, for example, that could have caused a dent in a wing or on an engine fan blade. We're looking for leakages. We're listening to how the hydraulic pumps are working. We're looking at all of the static probes and the pitot probes, and that everything basically looks the way it should. But we don't have the possibility to look for fatigue cracks in fan blades, okay? We look for obvious damage. So in the case of the 737, I tend to kind of move the fan around just to hear how it's spinning, listen to strange noises and see each fan blade to see if it's been bent by a bird, for example. But a fatigue crack is a microscopic crack. Okay, the only way to find a crack like that is during dedicated, what's called non-destructive inspections, where trained engineers will get each fan blade down, they will paint it with specific paint, and then they will go over it with kind of like an X-ray machine or similar types of machine to try to look down below the surface and look for these cracks, right? It is impossible to do, even for a trained engineer, when the aircraft is at stand. This is why this is done at very specific, regular intervals in the life of an engine, to make sure that these kind of fatigue cracks doesn't appear. So the next question comes from Alex Fowler on Twitter, and it says, the fan looked like it was going faster than just free spinning. Was it still producing some thrust? Okay, great question, by the way. So we've probably all seen this fantastic video made by one of the passengers of the engine after the failure. And you can see how the front of the engine is still spinning, albeit with some quite bad imbalance. So the whole engine is kind of shaking. And then you see that there's still flames coming out from the back of it. Now, that movement of the fan is what we call windmilling. All right, so it looks like it's spinning really, really fast, but that's just because of the speed of the aircraft. When this video was made, you can see that the slats are extended, so it's likely that they are on their way in for landing at that time. But the speed would still have been, maybe around 180 knots or so. And just like your kid's kind of wind spinner, when they blow hard on it, it's going to spin faster. It's the exact same thing happening to this engine. So the answer is no. This engine was not producing any thrust at this stage. You would not want it to produce any thrust, because if you would accelerate an engine with that much imbalance and that much damage, you could potentially cause even more damage to the aircraft. You know, it might be spitting pieces out. And also, obviously, at that point, the fuel, hydraulics, everything would have been cut off, because that's one of the first things that you do when you have an engine fire indication, which these guys obviously had. And if you just stay with me, there is more questions coming up again around the fire. And I will be talking much more about the fire suppression of the 777 and the fire handle and how it works in just a few minutes. All right, so the next question comes from Facebook. I can't see who actually wrote it, but it says, on the 777 incident, the right engine went out, but the pilot made only left turns. Would that be harder to turn? Or if he turned right, would be too forceful and dangerous? Any typical insight regarding an engine out and which way to make turns in an emergency? Okay, that's actually a really great question. So I've made a couple of videos about how we deal with engine failures after takeoff, right? Actually, in the Mentour Aviation app, there is a whole playlist in 360 explaining exactly what we do. But what you need to understand is, on a 2-engine aircraft, if you lose one engine, right, then that engine used to produce thrust, pulling the aircraft forward. When it fails, it now produces drag instead. So instead of having a force that pulls forward, it's actually going to be a force that kind of pulls back. On the other hand, you're going to still have the operating engine on the other side that's going to pull forward. So that will cause what we call a thrust asymmetry, right? It effectively means that the operating engine is going to try to turn the aircraft towards the side of the inoperative engine. So in this case, the left-hand engine was still operating and they were making left turns. So he's asking, why would they be making a turn left when the aircraft wants by default to turn right? Okay, so when an engine failure happens, the first thing that pilot flying is going to do is to try to control the aircraft. In the 777, there is actually a system that will help to put rudder in when it feels that there is an engine failure, at least if it's a normal engine failure. So this means that initially the pilots will be focusing on just climbing straight ahead, right? Until they have the aircraft fully under control and they have the correct amount of rudder in. When they have the correct amount of rudder in, right, after that, they can do whatever turns they want to do. Okay, there's not going to be any difference between turning left and right, because the aircraft is trimmed out in this new thrust configuration. The reason that they chose to turn left, in my guess, is that United Airlines more likely have an engine out procedure when they take off from runway 25 in Denver. And that's because the Rocky Mountains are coming up, right? Really high terrain just to the west of the airport. And there's no way that the pilots will want to fly in over high terrain with only one engine remaining. So it's likely that they have a procedure that, for one reason or another, turns them to the left. So that's likely why you saw them making a left-hand pattern, but to answer your question, they could have turned right as well. It wouldn't have been a problem, it wouldn't have been more dangerous. They would still, once they have the speed under control, be turning with about 25 to 30 degrees of bank, even single engine, as long as they're up above their minimum maneuvering speed. Okay, so another question here, which is a great one from Duali on Twitter, and it says, how similar is this to the Longtail 5504 flight the same day? Was it a similar engine, and how similar were the failures? Okay, so this is actually quite incredible. On Saturday, there was another engine failure, this time in Maastricht, in Europe, where a Boeing 747 had some type of a problem with one of its engines, which was also a Pratt & Whitney 4000 engine. All right, so it's essentially the same engine, but there is a major difference. In the Maastricht case, where the 747 failure happened, it is a smaller fan, all right? So it doesn't have the same fan blades, so it is a different type of engine, even though it is the same model. But the similarities are striking, as in the Maastricht case, the engine failure also started showering parts of the engine down on, you know, some vehicles and some houses below. And in the Maastricht case, there was actually at least one person injured on the ground as well. But there is a major difference between the two, and that is in the Longtail case, that's in the accident that happened in Maastricht. there was smaller pieces that fell down. So either from the turbine or from the compressor stages. So it wasn't a fan, which means that this is a completely different type of failure. So even though it is essentially the same type of engine, it's still a Pratt & Whitney 4000 engine, this is likely to be something completely different, all right? But there's no question that it was a terrible day for Pratt & Whitney on Saturday, right? 2 of these engine failures, very similar pieces falling down onto the ground below. It's not good at all. Right, so this is another great question. It's sent in from SMT on Twitter, and it says, were the engines shut down in response to an engine failure with the fire extinguishers deployed? And was there a risk of the engine detaching itself from the aircraft? Okay, that's actually 2 questions, but I'll allow it. Yes, so when we, the pilots, get an indication of an engine failure or fire, we respond slightly differently, okay? A fire is something that you need to respond to quickly, same as with a severe damage, because you want to make sure that the engine is secured down, right? That the failure does not continue to cause damage to the rest of the aircraft. So in the case of an engine fire, you need to do, at least in the 737, something called memory items. It's possible that it's slightly different on the Boeing 777. But it includes things like, once the pilot flying has the aircraft on control, the pilot monitoring has identified which engine it is, which by the way is a bit easier with a fire because you have an illuminated fire handle in the cockpit. The thrust will be reduced on the affected engine. The fuel switch, the engine start lever, will be cut off to stop fuel from going into the engine. And then you will pull the fire handle. Now, the fire handle is fascinating because it has 2 functions, well 3 actually. It shows, you know, which engine is on fire. It isolates the engine, and it arms and potentially discharges the fire extinguishers, right? So look at those in turn. It will indicate a fire when 2 fire loops inside of the engine feels that the temperature goes above a predetermined limit. And when they feel like, okay, it's now gone up to a certain temperature, we will get an overheat warning, which is different from a fire. Then if it goes higher, the same system will trigger a fire warning, and that will illuminate the fire handle and give us the fire bell and the master caution and the fire caution as well. Now, when you pull that handle up, it will isolate the engine. So it will stop the fuel from coming into the engine. It will stop hydraulic fluid from coming into the engine. It will isolate the thrust reverser circuit so that it cannot extend reverses. It will also isolate the electrical circuit. So it will take away the generator, and it will stop bleed air from being taken from the engine. So basically we're now kind of making sure that nothing that can burn can go into the engine, and that we're not taking anything out of the engine that might be faulty. Then we can turn the fire handle. That's to discharge the fire extinguisher into the engine. Now the fire extinguisher system on the 777 and the 737 is actually quite similar. We have 2 fire extinguishing bottles. Those are filled with halon, and they're pressurized by nitrogen. In the bottom of these fire extinguisher bottles, which are actually round, they look like little footballs, there is what we call a squib and a disc that seals it. When we turn the fire handle, and it's really important that you turn it all the way, you'll feel the click when you actually discharge. That will send an electrical impulse to the squib, which is a electrically activated little explosive device. That will then break the little disc, and because the halon is pressurized, it will then be pushed out into the engine. The way that halon works is that it will remove the oxygen from the engine. Remember that fire requires 3 parts in order to burn. You need oxygen, you need heat, and you need fuel. So basically we take away the oxygen. In theory, that will remove the fire. Now, we've seen this video that's gone viral from the United Airlines event. So you know that even though they had done all of these actions, there was still fire in this engine, and the NTSB is now trying to figure out why that happened. Once again, that's why it's so important that any parts that are found on the ground is being given over to authorities, because it is a possibility that there was some damage to, for example, the fuel lines that could have continuously then let fuel into the engine. We don't know. We're going to have to wait until the NTSB has done their full investigation of this. But in theory, this is the way that the fire extinguishing system works. And you can use both fire extinguishers into one engine, or you can use one for one engine and another one for the other engine. But if you need to do that, you're having a really bad day. So that brings us to the second part of the question, which is, could the engine disattach from the aircraft completely? And I've made a video about how the engines are attached to the wing, which is quite fascinating actually. You can check it out up here. But the answer to that question is most likely no. Yes, a catastrophic explosion of the engine can rip it off. Yes. But this kind of failure, the way it looks to be a fan blade that has disattached, the engine is actually constructed to be able to take that amount of energy. So it's very unlikely that something like this could ever cause an engine to actually fall off. Ooh, this is a great one from FailApp 2.0 on Twitter. Did Pratt & Whitney use hollow titanium alloy fan blades to cut costs? Okay, so those of you who have been following this incident would have known that the engines that are involved in this incident is a Pratt & Whitney 4000/112 model engine. Okay. These engines was used on a lot of the older Boeing 777s. Okay, this aircraft is over 26 years old, and the newer 777s are using the General Electric 90 engines. Pratt & Whitney, when they constructed this engine, they had already a 4000 model engine. Okay, it was used on the Boeing 747, but it had a smaller fan, I think 94 or 96 inches. Now they needed to construct a fan blade that had a diameter of 112 inches. Right? That's a huge fan. And when you start making fan blades bigger, well then they will become heavier as well. So traditionally, the fan blades were made out of solid titanium. But when you have a fan blade that is that big, using that method would just make it too heavy. And not only would the fan blade and the disc that needs to hold the fan blades become heavier, because they becoming heavier and because of the speeds that they're spinning with, the heavier fan blade you have, the more energy it will have in case it would rupture. And you need to have a containment ring that can take those fan blades. So with a heavier fan blade, more energy, a heavier containment ring and a stronger containment ring as well. The containment ring, the one that you can see in these pictures, that's the yellow part of the front part of the engine there, it's made out of woven Kevlar, right? And it's unlikely that that technique would have been able to be used if the fan blades was that much heavier, or they might have had to use double layers of it. Well, in all, it would have just made the whole engine extremely heavy. So they had to come up with a way to create these fan blades in a reliable way. And what they came up with was this monocoque structure, all right? They're basically hollow inside, and that reduces the weight of the fan blade enormously. But they're not alone with doing this type of fan blades. In fact, Rolls-Royce also have a hollow type fan blades, but they use a completely different manufacturing process. So the answer to your question is, did they do it to cut costs? No, they did it because of the physics behind making engines. What will happen? Well, that we don't know, all right? Because this is not the first time that these type of engines have had issues, right? The Pratt & Whitney 4000 engine on the 777. Now, you would have all noticed that both the FAA and Boeing and also the Japan Civil Aviation Bureau, and I think latest also the CAA in the UK, have gone out and recommended that all 777s with these particular engines are grounded. Now, the way that they're doing this is that they say we need to figure out a new inspection process or a new inspection interval for these engines. But why do they do that before they know what actually caused this failure? Well, that's because what I said before. Back in 2018, another United Airlines Boeing 777, curiously also flying to Honolulu, experienced a failure to the number 2 engine, the right-hand engine, which was very similar. They were up at 36,000 feet when the crew heard a large bang. They felt vibration, the aircraft autopilot disconnected, and they started rolling to the right. The pilot flying took control of the aircraft. They started looking into engine instrumentations, and they realized that they had a failure on the number 2 engine, which they then dealt with. Okay. In the cockpit on that incident, there was another pilot that was jump seating. Now, he was sent back to take a video to see what they were dealing with, and the video that he came back with and that was subsequently released in the investigation showed an almost identical failure to what we saw last Saturday. Okay, there was one fan blade who had disattached from the base of the engine. The next fan blade down had cut in half approximately. The cowling had fallen off down into the sea in this case. And on that occasion, the crew just continued to fly towards Honolulu. They were only about 120 miles away, so they could come in and do a visual approaching for runway 08 right, I think, in Honolulu. Anyway, there was a full investigation into that incident. And in that investigation, the NTSB found that, the inspection that had been done on these fan blades, because on fan blades you have to do regular of these non-destruction inspections and check each fan blade. You do it with a special technique, and in the case of the Pratt & Whitney, they had delivered a new technique, an emerging technology. And because it was an emerging technology, they had gotten a kind of a suspension from the amount of training that the engineers needed to do before they were allowed to do these inspections. So it turned out that while a normal inspection is done by an engineer who's done at least 40 hours of in classroom schooling, and then 1,600 to 1,900 hours of on-the-job training, these guys that was doing this inspection only had about 40 hours of instruction on this particular technique that they were doing. And they had found this indication of this fatigue crack. Okay, there was notes made about this fatigue crack back in 2010 and then again in 2015. But each time, because of the lack of training, these inspectors didn't understand the significance of it. In fact, they thought that it was a problem with the paint they were using in order to do the inspection. So they basically sent it back out. Okay, not understanding that what we're actually looking at was a fatigue crack, and that eventually led to this fan blade breaking off. All right, and that was a big no-no. Because of that, actually, these engines was mandated to have an inspection of the fan blades each 6,500 cycles. All right, cycle is a takeoff and a landing. But then again, now in December 2020, a Japan Airlines flight, I think flight 904, also had a failure with this particular engine. In this case, it was on the left-hand side, the number 1 engine that failed. And when the crew once again got down safely on the ground, they also found a fan blade that had broken loose. Now, we don't know if these 3 incidents are connected, but because of the similarity of them, and because it is the Pratt & Whitney 4000/112 engine that is involved in each of these cases, the civil aviation authorities are just taking it safe, right? They're just saying, okay, we don't know exactly what's causing this, if this is an inherent problem with these fan blades. Let's put them down on the ground, let's inspect all of them thoroughly, and because of that, the 777s that are attached to these engines are grounded until these inspections can be made. Okay, as a final question, this is something that I personally want to really emphasize. So this is a question from Michael Tavel at Twitter, and it says, what is the effect on grounding the 777 on Boeing? First, it started with the MAX, then with the COVID, and now 777. Can a company like Boeing survive all those hits? Now, I don't know, if Boeing can survive all of those hits regarding, for example, COVID and the MAX. It's separate issues, okay? But I want to really emphasize something that's important here, and that, first of all, the amount of Boeing 777s that are affected by this grounding is about 10% of all of the 777s built. So that means I think it's 69 flying and 59 that are in storage at the moment. So it's a small part of the overall 777 population. Another thing is that you have to really separate the engine manufacturer from the aircraft manufacturer in this case, right? That's really, really important, because if you're a customer, an airline, and you buy a Boeing 777, you actually have a choice of 3 different engines, right? You can buy it from the Rolls-Royce, the Trent 800, or you can buy the Pratt & Whitney 4000/112, or you can buy the General Electric 90 engine. And what you choose, that's going to be up to the airline. In fact, the purchasing process is separated, right? You buy the aircraft, and then you buy the engine, okay? So to blame the Boeing 777 for this and to even put a slight amount of blame on Boeing is unfair. It's like you being a house owner and you know, blaming the house for the boiler not working, even though you bought that separately later on. So I don't think that Boeing will get much heat from this at all. They are going to be there, they're going to be helping with the investigation, but the Boeing 777 performed beautifully, right? On all of these 3 occasions that I mentioned earlier, the crews have been able to fly the aircraft, they've been able to come in and land, and the passengers have been safe. So the 777 has done a great job here. It shouldn't be affected in any way. But I think Pratt & Whitney, and especially the Pratt & Whitney 4000/112 engine, is going to get a lot of scrutiny because of this. We don't know what caused it yet, so it's still up to the investigation to come up with this, but I did want to really highlight this, that there shouldn't be any Boeing bashing because of this incident, all right? This is an engine manufacturer thing. I really hope that you love this Q&A, and I hope that I have earned a subscription from you. If you think so, that's great. Make sure that you highlight the little notification bell as well, so you know when I'm doing these spontaneous videos or my regular Friday videos or live streams. If you have more questions about this or anything else, well then send it in to me on Twitter. You can put it here in the comments below, or you can get it on the free Mentour Aviation app, or join my Discord server and post a question there, all right? Love to hear from you, and I'd love to do more videos if you think that, you know, that there are questions that warrants it. So until then, have an absolutely fantastic day, and I'll see you next time. Bye-bye.